Students, today's lecture is about clean dryer and spray dryer. In the previous classes, we had already discussed about various types of dryers. Like we discussed about drum dryer, we discussed about cabinet dryers, we discussed about tunnel dryers, we discussed about conveyor dryers or belt dryers, we discussed about rotary dryers, and every dryer had its own advantage over the other dryer, and they were used for different food items. Let me consider the example of drum dryer. The drum dryer had higher energy rates or energy efficiencies and high drying rates, and they were suitable for slurries in which the particles are too large for spray drying. For example, if we are having high viscous foods, so these high viscous foods can't be passed through the nozzles. These nozzles are an important ingredient or important component in spray drying, through which we pass the liquid into the drying chamber. So high viscous foods can't move through small nozzles in which they are having an aperture in micrometers. So food which are having high viscosity, they can't move, they can't be passed through the nozzles. So as a result of which the drying efficiency will be very less. So that's the case for drum dryers. That means if we are using drum dryers for slurries, then the energy efficiency will be high, and also the product will be efficiently dried. So today we will be discussing about clean dryers and spray dryers. So what are clean dryers actually? These are two-story building in which a drying room with a slatted floor is located above a furnace. What does it mean actually? Hypothetically, if I will be telling you it, like I have the here the picture is like in the at the bottom, if you will see the rectangular the second story, there are some foods that have been placed, and from the bottom, as you can see these arrows, this is the heating source, and as the heat flows from the lower story up to the second story, it takes heat with it. So as a result of which the heat dries the food that has been placed on the first floor, and as a result what happens, evaporation takes place, or you can say drying takes place, and the moisture that is present on the in the foods will get removed away. And for generating this heat, we are mostly using either wood, or sometimes we are using different boilers. For the boilers, we have to provide the heating source, and the heating source is mostly heating medium is mostly it's wood. The wood is being burned down, or sometimes steam or water is being evaporated, and as a result of which it's used as a heating medium to heat the foods. So you can say that the hot air and the products of combustion from the furnace pass through a bed of food up to 20 centimeters deep, and they have been used traditionally for drying apple rings. So if you know the example of malt production of barley, in the barley, when we are converting the barley into malt, there are three processes that are usually like we are keeping the barley in the liquid to germinate. Then we are controlling this germination by heating the barley, and the step is called cleaning. And in the cleaning, what we are doing actually, we are placing the barley on the floor, and we are giving the heat from the bottom of the bottom story. So the barley takes the heat, and as a result drying takes place and the malt is being produced. So you can say that this cleaning is mostly used to dry the traditional homes, like for the drying of apples or the drying of the barley malt, but limited control over drying conditions are here, and drying times are relatively long, because it consists of uncontrolled system. Manually we have to perform the activities here. So all the time we have to spread the barley, we have to what we have to do, we have to turn the product regularly. And by doing this, then it gives you the low control over the whole process. The large capacity and easily constructed and maintained low cost. Here that means it can be made of high capacity. Like if you will make the story of the house in which you are doing the cleaning, if you are making it in a large area, so the capacity will be increased, and it can be easily constructed and maintained at low cost. So that means here, due to the low control on the item to heat it, so it means it's not efficient drying system. So in the second type of dryer are the spray dryers. What spray dryers are actually? These are the, see here in the pic, if you will see, we are having a spray drying chamber, we are having a cyclone, we are having an exhaust, we are having a scrubber for recovery, and we are having a product on the red, if you will see a red arrow here. So we are having a feed. If you will see the arrow on the left hand side on the top of the spray drying chamber, we are using the feed, that means a food which we have to heat or which we have to dry. We are passing this into the spray drying chamber. And here if you will see this red, in which the air has been written, and atomizer, we are spraying the feed as well as air into the spray drying chamber. And as a result, this air is hot air, and the feed that is flowing into the drying chamber, they get in contact with each other, and as a result of which they dry. And see, this atomizer, what it does actually, it decreases the surface area of the liquids. And as you know, less the surface area, more will be the evaporation. So it increases the surface area. It increases the surface area. So as it increases the surface area by making the droplets, by moving the feed into small droplets, and it gets in contact with the hot air, and it gets easily evaporated. So as such, when it gets easily evaporated, it moves down into the cyclone. What this cyclone does, because both the air as well as the dried powder, because the feed has been now converted into the powder, and it moves into the cyclone. As soon as it moves into the cyclone, this cyclone is actually a separating medium, is a separating system, you can say. It creates a vortex, and the lighter air or the hot air which is still present there, it moves on the top, and the powder that is still there, it moves to the bottom. And as a result, the product moves at the bottom side. As you can see, this red chamber where the product has been written, the product we are getting it from this side, and the air, it's moved through the exhaust, or we recover this air. So a fine dispersion of pre-concentrated food, that means 40 to 60% moisture. Because if the moisture is too high, like let me consider the moisture is up to 100%, or the moisture is above 80%, so that means it's highly diluted, and the efficiency what we are getting in the final product will be less. The concentrated product will be less if the moisture is high. So that means prior to drying, what you have to do, you have to first concentrate the product. So as a result of which, when you concentrate the product, the moisture is already being removed. So the moisture which is mostly used is 40 to 60%, is first atomized. Atomized means you are throwing to form a fine droplets. Atomized means when you are atomizing, or when you are spraying the fine droplets from the liquid and then sprayed into the or counter current flow of heated air at 150 to 300 degrees centigrade in a large drying chamber. As I showed you here, this is the spray drying chamber. You are throwing the feed as well as air into this drying chamber, which is already hot up to 150 to 300 degrees centigrade. This co or counter current means if it's a co current, then both the direction of the feed, if you are seeing on the top here on the spray drying chamber, it has been written by an arrow top that feed is thrown into the drying chamber as well as the air. The direction of feed as well as the air moves from the top to the bottom of the drying chamber. So that means the direction of feed as well as air is same. But if it's co-current that has been written here, then the direction of the flow of air is from the bottom side and the feed is moved from the top side. So what will happen? There will be the feed which is moved into the chamber, it will be suspended into the chamber. So when it will be suspended into the chamber, as a result of which what will happen, there will be higher efficiency heat transfer rates, or higher efficiency drying will take place, and as a result what will happen, then it will be efficiently dried as compared to the co-current. But in case of co-current, in case of co-current direction, it's having a little bit less efficiency as compared to the counter current. So, and it enables the transformation of feed from a fluid state into the dried particulate form by spraying the feed into a hot drying medium. So that means the fluid, the pre-concentrated fluid, is thrown into in the form of spray into the hot drying chamber. So as a result of which the drying takes place. So feed can be a solution. What type of feed or what type of food can be used? It can be a solution, it can be a suspension, it can be a dispersion, or it can be an emulsion. And the dried product can be in the form of powder, granules, or agglomerates, depending upon the physical and chemical properties of the feed, the dry design, and the final powder properties desired. So the final product which you want is in the form of granules, or it's in the form of powders, or it's in the form of agglomerates. What is actually, it's the whole fun is being done by the atomizer. There are so many types of atomizers. When we are having different types of atomizers, like ultrasonic nozzles, or we are having different types of nozzles, atomizer or spray nozzles. So depending upon which type of atomizer you are using, some are having less aperture sizes, like up to 10 to 500 micrometers, or some are having more, or some are having up to 100 to 200 micrometers. So it depends upon the atomizer, which type of atomizer you are using. So, and also it will affect the final product. So its history is that it was first of all developed in 1870s, when during the World War II, when there was sudden need to reduce the transportation weight of the foods and the other materials. So the scientists were seeing that we should have some mechanized system that will decrease the weight of the food. So this is a type of dehydration. When we are dehydrating the food, obviously we are decreasing the area, we are decreasing the size, we are decreasing the weight of the food. So that, as if you are saying about spray drying, it turns it into a powder, like skimmed milk powder. The powder which it can be easily transported from one place to another. And the basic steps that are necessary in the spray drying process is that first you have to concentrate the fluid or concentrate the liquid which you want to dry. Then we have to go for atomization. Atomization, as I have already told you, what's atomization is the to spray it into the drying chamber. Then droplet air contact. What's droplet air contact is that when the atomizer makes or sprays the liquid or the fluid into the drying chamber, it turns it into a droplet, fine droplet, and also the hot air is moved or into the system. The hot air and the droplet, when they get in contact with each other, then evaporation will take place, or the drying will take place. When the drying will take place, this droplet, it will contain both the liquid, it will contain both the moisture part as well as the solute part. That means it will contain both little bit water, it will contain more water as well as the solute which we want to dry. So as soon as it gets in contact, so the water will get evaporated and the powder and the droplet will be converted into a fine powder. And when it will be converted into a fine powder, we still have two things in the chamber. One is air that is still present there, and the powder. This fine powder, it will be separated. We need to separate both of them. We need to separate both the powder as well as the fine droplets. So when we need to separate them, we are using cyclone separators. What are cyclone separators? It works on the basis of cyclone, or it works on the basis of vortex. When vortex is the lighter particles like air, it is moved out of the chamber, and the powder which is little bit heavier than the air, then it moves on the bottom. So by that way we are separating both the systems. Sometimes what happens, sometimes little bit wastage of these powder is the fine powder also moves out of with the air. So this is one of the disadvantage here, that these cyclone separators are being used, and this prevents this wastage. And then the droplet is being dried. Then concentration, as I have already told you this thing, that means concentration is feedstock is normally concentrated prior to introduction into the spray drying. What's atomization? The atomization stage creates the optimum condition for evaporation to a desired product having the desired characteristics. And droplet air contact, in this atomized liquid is brought in contact with the hot gas. And droplet drying, moisture evaporation takes place in two stages. During the first stage, there is sufficient moisture in the drop to replace the liquid evaporation at the surface, and evaporation takes place at a relatively constant rate. And in the second stage begins, there is no longer enough moisture to that is in the saturated condition. So as a result of which, the evaporation then depends upon the diffusion of the moisture through the shell, which is increase in the thickness. Then separation is done by means of cyclones, by means of bag filters. Bag filters, we're having little bit bags, and these bags are separating both the systems. Electrostatic precipitators, we are having precipitating medium or precipitators that precipitates the powders. And as a result is then web scrubbers are also there. Wet scrubbers, and often used to purify and cool the air so that it can be released to the atmosphere, because it's sometimes it's hot. And design and the critical elements that are or the components that are very essential in the spray drying is what are they? In the first is, it's mainly the atomizer, because atomizer must fulfill several important functions. And what these functions are, it must disperse the feed material into small droplets, which should be well distributed within the dryer and mixed thoroughly with the hot gas. Until and unless the contact system is not there, or the contact is not being met between the hot air and the droplets, then efficient drying will not take place. The droplets produced must not be so large that they are incompletely dried. nor so small that the product recovery is difficult, because if the particles that are being produced are larger in size. When they are larger in size, larger the size, less will be the evaporation rate or drying rate. So as a result of which the product may be inefficiently dried. And also, if it's very small, as I told you, it can get wasted into the cyclone separators. When we are separating the air and the droplets, if the size is too small, it will be so lighter that during the airflow it will take the fine powder with it. So wastage may take place. Also, it must not act as a metering. It must act as a metering device. Metering device means when the atomizer rotates, it takes or it controls the rate at which the material is fed into the dryer. So that means the atomizer is the heart of any spray dryer in the spray drying system. Small in size, big in importance, in installation, the right atomizer is essential to spray drying process there. You can see this is the atomizer. This fine spray is thrown into the drying chamber. This is one of the example here. So as I told you that the flow of the air can be co-current flow, counter current flow, or it can be mixed flow. Then in co-current, what I have told you is that spray and hot air enters in the same direction, and in the counter current, spray and hot air enters in the opposite direction. When they move in the opposite directions, the contact between the droplets and the air will keep the feed in the suspended position, in the suspended form, and as a result maximum heat transfer can take place. And sometimes they are used in both the ways, like in co-current as well as counter current. So if you will see this thing from the top, as you can see, inlet air, the air is thrown into this through the filters, and then the filter is passed through the fans and into the heaters. It heats up the air, and when the air is being heated, it is then thrown into the chamber. Then you can see from the downside of this big chamber is the feed. This feed moves from the downside, and as a result this can be considered as a counter current. Then it moves into the cyclone. Then fine powder is being separated, and then bag filter is there, or cyclone, and in the outlet is gas, and the dust means that it will be the powder itself. So in the last slide, what we have, spray drying chamber, what it actually has, air within the chamber maintains a flow pattern preventing deposition of the partially dried product on the wall or atomizer. Sometimes you can say that inside the drying chamber maybe some amount of powder will be deposited on the walls, but it's being prevented because what? Because due to the flow pattern or the air that is being flown through, it does not allow the powder to get deposited on the walls of the deposit. And also the air movement and the temperature of inlet air influence the type of the final product. These are the two things which are very important here. Thank you so much.